When we want to look into a spatial dataset, one of the most general solutions is visualizing each data point on top of the map. However, when we have more data, this could lead to overlapping and unreadable results. In this demo, we present a system for efficient selection of large-scale geospatial data. Spatially, the system supports the following desirable features. First, objects shown should not be too close to each other. Secondly, the selected objects should represent as most of the dataset as possible. Thirdly, the selected objects should follow the consistency constraints after user interactions such as zooming and panning. We demonstrate the system based on 2 real-world datasets. For the real estate data, the suburb selection gives us an idea of how the visibility constraint and representativeness work. Here, our algorithm selects 15 suburbs out of more than 300 suburbs in Melbourne, and each suburb is represented as a spider chart. We can see that Box Hill North is close to hospitals, supermarkets, shopping centers, but has a relatively long distance to the CBD. The western suburb, Burnside, has some similar features, except that the house price is much cheaper than the east suburbs. When we click on Box Hill North, we can see those suburbs that it represents, such as Box Hill South, Burwood. Now we come into the individual property selections. Without the sampling, it could be a mess on the screen. Here, our algorithm selects 20 properties on the current map window based on user-defined attributes. Each selected property is represented as a circle on the map, and the size is based on the number of properties that it represents. We can increase the total selection number from here, and the attributes defined by the user will affect our similarity function, and thus affect the selection results. When we click on one property, those properties that it represents will be shown as small circles on the map, and a detailed information view will be displayed on the right side. Here, we design a colored table to show the detailed information of the clicked property and those properties that it represents, sorted by the similarity score. We can see that all those properties are quite similar to the selected one, and property 11 has a cheaper price compared to the selected one, and property 19 is closer to the shopping center. The consistency restrictions affect how the objects appear and disappear after user interactions. For example, here, when we pan the map, those previously selected properties that remain in the new map window will not disappear, and there will be new selected properties popping up in the new added region. When we zoom in, this previously selected property that is still in the map window will not disappear, but it might represent fewer properties. When we zoom out, the map window includes a larger region, but those selected properties in the previous map region should come from the previous selections. In the website, we also demonstrate our system based on the Twitter data. And we allow users to compare our results with some baseline methods such as the random and max sum methods. Please try the demo by yourself. Thanks for your watching.